Hello, everyone. We're back with another round of Turing Dev Talks. My name is Jose, and I'm turning in from Montreal, Canada. And today on the panel, we have Chitwan from India, and he is an ML scientist. And today, I'm so excited to talk about the classical ML and low-code ML as well. And without further ado, hi, Chitwan. How are you doing, and how is your day doing so far?
Hi, Jose. Thanks for having me. My day has been going great. I've had my meetings and I've worked on the project that I'm working on. Just one more meeting to do, and then I'm going to wrap my day. Yeah.
Nice. That's great. All right. So, could you please let us know a few ML project that you have been work on?
Yeah, sure. So at Turing, we work on a project which is known as Learning to Rank, where we want to rank all our software developers in the best order, like the best software developer at the first position and so on, so that our clients, our customers can have the best of the best software developers working for them. So that's a problem that we are working on. It's called Learning to Rank. Apart from this, previously I've worked on text generation tasks as well, where let's say, given an image, you want to generate a marketing copy or a marketing language text for that particular image, mostly related to clothing, fashion, and apparel. Yeah.
All right. So let's now dive deep into our discussion of the day. So, Chitwan, let's start to understand what are classical machine learning algorithms. How would you describe them?
Classical machine learning or machine learning means your computer learning from the historic data and trying to make predictions for the new observation. So that's machine learning for you. You can say that your machine is learning. So some of the classical machine learning algorithms are directly coming from mathematics and statistics, such as linear regression. Then we can talk about some algorithms like nearest neighbor, tree-based algorithm, decision trees, and random forest. So these are some of the
Okay.
classical ML algorithms that are being used to solve industrial problems today. Yeah.
Okay, great. So if you understand it correctly, the classical one is the one that you learn with the past, right? You have to store a large amount of data and check them to make the next decision. Is that?
Is that correct? That's correct. Yeah.
Great. So they use all kind of machine learning models, or like supervised, unsupervised, and reinforcement as well, or not? This is just for one kind of algorithm.
So classical machine learning algorithms are mostly used for supervised and unsupervised tasks. For reinforcement learning, we have a different sort of algorithms altogether. So you can say that mostly the classical ML algorithms or statistical algorithms are used to solve supervised and unsupervised problems. Yeah.
Okay, great. And that was classical machine learning algorithm, right? But how they are different from, I would say, neural network and ensemble methods?
Okay, so neural networks can also be used for the same task, training on data, past data, and wanting to make new predictions. But the main idea behind neural networks was to replicate the human brain. Human brain have these cells called neurons, which make us do certain actions that we do, day-to-day actions, basically. So we wanted to mimic those neurons, those cells, and create something which is known as artificial intelligence. So one of the major difference between neural network and classical ML algorithm is that it requires large amount of data and complex or heavy processors to process the entire algorithm. So you can say that this is one of the major difference. But yeah, you can say that it also leads to quite effective results. Yeah.
All right. Got that. And would you say in the future they will be able to replicate our brain? 100%, or no? It will be impossible.
Right now, it's too soon to comment on anything. But yeah, it's work is in progress. Like this community is working very hard on the different problems, and this being one of them, trying to replicate the human behavior more and more. So one day, who knows? We might have an artificial intelligence robot that's just like us.
Yeah, I agree. All right, and I've seen people comparing deep learning with classical machine learning. And so, in your understanding, what do you have to say about this? The comparison between deep
So,
learning and classical machine learning.
so we can say that at a structured level, structured data level, there can be some sort of comparison, training on historical data and making predictions. But when you talk about some different unstructured data, such as images, videos, text, sound, classical ML algorithms don't perform well in those cases. There comes your neural networks. So they are extensively used in text translation language translation problems, language modeling, speech to text, and some computer vision tasks like image recognition. So these are some of the areas where neural networks tend to perform better than classical ML algorithms. But yeah, on the other hand, they also require heavy resources, heavy processors to process these algorithms and large amount of data as well.
Gotcha.
Yeah.
And do you think they will coexist in the future? I mean, classical machine learning, deep learning, or do you think that deep learning will replace classical ML? 100%.
So from my experience, I can say that for tabular or structured data, where or day-to-day business decisions that the business people take, that's much easier for them when they use classical ML algorithms because they're interpretable. And on the other hand, neural networks are complex black boxes that we cannot use to make business decisions. But yeah, uh, neural networks will completely take over the text, images, and speech-based tasks. But yeah, where we want to take crucial day-to-day business decisions, directly looking from the numbers, their interpretable models are a necessity, and classical ML algorithm provides that.
Nice. Thank you for sharing. And one follow-up question about this. In your experience, okay, regarding your experience, if they are news that are fresh in this world, okay, in machine learning, do you think they need to learn classical ML, or it's better than go dive deep into deep learning and then just go on?
So when you want to learn something, you take steps, right? You go to first step, then you move to second step, and so on. So classical machine learning or statistical algorithms are the first step. So you got to master those, you got to learn those before jumping onto deep learning models, because quite of them are inspired from the classical ML, and some of the training processes and concepts behind them are common. So it's necessary to learn the classical ML algorithms first, and then move to deep learning algorithms.
Nice. All right, and move on. Okay. Apart of these traditional and intensive methods, there is also a low code machine learning, right? Could you please explain me, just brief, what is a low code machine learning?
Okay, so low code or no code machine learning is something which requires very less or negligible coding. So this is specifically for those professionals who are not very comfortable with programming or coding in general. Also, you can say that they save a lot of time in terms of coding, since you're not coding and you're just doing some drag and drops. That takes uh, quite a less time. So these low code platforms are being used today. Some of them, I believe, are obviously AI, make AI. These are some of the tools that I'm aware of. But to be honest, I feel like that there's programming is a must for machine learning, and you cannot insert certain business decision until at least as of now into low code tools. You need to know programming logic to insert some business decisions.
Oh, gotcha.
So yeah, that's my opinion on that.
Okay, got you. And what benefits, okay, does it provide over the traditional methods?
So these are some. One of the major benefits or disadvantage, you can say that uh, you don't need to have much experience with coding. So a person who is not a software developer, or someone who doesn't know much of coding, coming from a different field, let's say an MBA, can also use low code or no code platforms to build machine learning models. So this is one of the major advantage. for those who don't know coding.
What are the use case for low code machine learning?
So the use cases that we're working on coding problems or code machine learning that can also be attempted using low code or no code problems as well. So you can say that there can be an overlap between use cases.
And when it comes to target personas, who can use that?
So again, as I mentioned earlier as well, no code or low code platforms are for those who are not much comfortable with coding or those who are coming from a different background. So low code or no code platforms are basically target those people. They can use these platforms.
Interesting. All right. I'm sure this would give our developers a great idea of what low code machine learning is. And here I would like to call upon our developers, fellas out there. Okay, if you have 3 years of experience and are confident with your tech stack, you can head out on turing.com/jobs and apply for the job that you are suitable for your tech stack. We have jobs for machine learning, for Python, Java, C#, React.js, Angular. We have jobs for over 100 combinations of tech stack. Okay, go to turing.com/jobs and apply for the job that is suitable for your tech stack. And if you are enjoying this video, if you are enjoying this content, give me a big fat thumbs up. Give us a big fat thumbs up for this video. And right down below, what more I would like to see in the upcoming video. And we're going to make a video for you. Okay. Don't forget to subscribe to our channel. If you are not subscribed already, it's free. You just need to click in the red button below. Okay. Do it now. And then you make sure you are not, you be aware of when we release a new video. And come back to you, Chitwan. This has been a great discussion so far, and I think it's time to bring our talk to a close. But before I let you go, could you please share with our developers some tips and how they can, learn more about classical machine learning and also low-code machine learning as well? How would you learn?
Okay, so my advice to all the developers would be to start from basics. Make sure that your basic skills, basic mathematical skills, specifically statistics, probability, linear algebra, calculus. These are some of the topics are you are comfortable with these. Then move on to classical ML algorithms. Try to learn what is happening under the hood. Coding them is not much of a problem, but yeah, you must be aware of what is happening under the hood. What input is it going to take? How it's going to process the data, and how the output is going to look like, and how you are going to interpret that output for your business. So this would be some of my advice. Once you are thorough with these things, then you can then it's your choice. If you have basic coding skills, then you can go for low code or no code platforms. But if you have a sufficient experience in coding, then you can also write code for that. Yeah, but again, the thing that remains constant is the understanding of how you're going to use that algorithm to solve the business problem.
All right. So thank you for your advising. Okay. Thanks a lot, Chitwan, for sharing your experience. I hope our audience enjoyed this as much as I did. Okay. And that's a wrap from our end. So if you guys have any question, any query, feel free to reach us at support@turing.com. Raise your ticket there. Send us an email. Make a comment here with your question. We're going to reply then for you. Okay. As that said, thank you all for sticking to the end. Give us a big fat thumbs up for this video. Subscribe to our channel. And don't forget to keep your learning spirit alive. Thank you again, Chitwan, and hope to see you again next time.
Thank you. Thanks for having me.